Welcome to CSE 31. So this is an extra lecture video on how to convert MIPS to machine code. So this is not really lecture 17. I will record another video on lecture 17 probably at the end of this week or next week. So this video's purpose is just to help you review how to convert MIPS instruction into machine code. So that will be helpful for your midterm exam next week. Okay, so for this special video, I'm gonna specifically talk about how to convert from MIPS instruction to zeros and ones. Okay, and then I'll have another video to talk about converting from machine code to MIPS instruction. Okay, so before we go into it, so let me ask you, how many types of instructions or how many formats of instruction does MIPS programming have? Do you remember? Okay. We have our format, right? Okay. And then what else? I have I format. What else? J format. Okay, so in this video, I'm going to talk about some examples within these three formats. So hopefully by the end of this video, you will have a better understanding and as well as know actually how to convert all instructions into zeros and ones. Okay. So for our format, the encoding or the encryption, again, so oops. So within the instruction or within the computer, instructions or programs are stored in 32 bits. Okay. So which means that whatever you do, the total number of bits of instructions is always 32 bits. All right. So now for our format, we will divide it into 6 fields. Do you remember what they are? Opcode, RS, RT, RD, shift, amount, and then your function code. Okay. And how many bits are in each field? You have 6-bit, 5-bit, 5-bit, 5 bits, 5 bits, and 6. Very easy to remember. You have 6-bit, 6-bit at the beginning and the end. And then in the middle, they're all 5 bits, right? Very straightforward. Now, how about I format? Same thing, but now I format only involves instructions with constant, right? So we don't need that many fields. So we'll have. So again, this is just a review of the conversion. If you are not familiar with that, probably you want to go back to the lecture probably 13 or 12 to go back into how they are partitioned. So for this one, I'm just going it a little bit quickly because I assume that you kind of remember the fields already. Okay, so I'll have same thing, opcode, RS, RT, but there's no RD and shift among anymore because shift among is only for shifting, right? So only 2 instructions will need shift. Okay, so the rest will be the immediate. So in this case, you have a bigger chunk of the bits to store the immediate, which is useful. Okay, so same thing, we have 6-bit, 5-bit, 5-bit, and then the rest will be for immediate, which is 16-bit. Okay, now what about J? So again, we say that totally you only have 32 bits, right? So which means that we have to somehow store the address because jump is what? Jump format is what? J format is to jump to a place, right? And you need to provide an address. So we still have the opcode and the address. Okay. And the opcode always stays the same as 6 because just to remember, hardware always wants to be consistent. So that's why you can see that RS, RT, and then the last three fields of R becomes this, right? So you can see that hardware is very stubborn. That's what they call hardware, right? They're hard. Okay. And now, because we have to reserve 6 bits for the opcode, which means that how many bits do we have for your address? 26 bits. And what do we do with the 32-bit address? Because we know that address is 32 bits, right? But we can only use 26 bits inside the instruction machine code. So which means that we need to do some sacrifice, sacrifice to the address. So we'll talk more about that later. Okay. So now let's focus on our format. All right. So let's use an R format. Okay. So for our format, okay. So let's use an example, the easiest one. Okay. Add register S0, register T0, and register A0. So basically, pretty much if the operands are all registers, this is in R format. Okay, so that's why it's called register R format, right? R. All right, so the first thing to do is to figure out how you put this information into the fields. Okay, so again, this is R format. So how many fields do we have? 6 fields. What are they? Opcode, RS, RT, RD, shift amount, and function code. Okay, all right, so now the next step is to try to match the fields to the original instruction. Okay, so this is the original instruction, right? So how do we match? Okay, what is S0? What is T0? So these are register number. So what we need to do is we need to go to your MIPS sheet. So let me stop the sharing and go to another screen. All right, so this is your MIPS sheet. In your exam, I will provide it to you, okay? And if you want, you can print it out at home, that's fine, okay? So that you have a physical paper to look into it, because I'm not sure whether you can use your computer during your exam, because your computer probably will be locked by the browser for the exam in the CAT courses. So I would suggest you probably to print out your MIPS sheet, or if you have another device, use it, that's fine. But just make sure that you can access a copy of this MIPS sheet, all right? So now, let's figure out what registers numbers are, okay? So at the MIPS sheets number 1, on page 1, these are the registers, okay, mapping. So I have S0, right? S0 is 16, S7 is 23, so you just keep on adding. So S0 is 16, and T0 is 8. So I have S0 is 16, T0 is 8. What about A0? A0 is 4, right? Good. All right. And then now let's take a look at the opcode and function code. So with our format, we have to be careful because we have 2 types of codes to determine the functions or the operation. So let's find the entry add. Okay. And you can see that what is add? Add is what? Register RS, put register RT, and save it into RD. Okay. And what is the opcode? So the last column tells you the opcode. Okay. So this is the first number is opcode, the second number is the function code. So that's why in add, you can see that you have 0 and 2 0. So this is not 20, this is hexadecimal. It's 20. Okay. So the first number is opcode, and the second number is your function code. So that's only for our format. So if you look at this column, you can see our format, whenever you see our format, there are always two numbers. The first number is the opcode, the second number is the function code, right? So from here, you can see opcode for our format is always unique. Opcode, our format, right? And the first number is always 0. So from here, you can see that for all our format, automatically opcode is 0. And the machine code for the instruction, the operator, depends on the function code. So the function code determines what kind of operation it is. In our format, opcode is always 0. So remember that, okay? So in this case, let me move back to my notes. Okay, so let's go back to the note. Now we know that add, the function code is 20, right? So I'm not gonna write it into base 10 because later on I'm gonna convert that into machine code anyway. So it doesn't make sense to write it into base 10, okay? So next, I have opcode. Our format opcode is already 0, right? And then what's next? RS. So which one is RS, which one is RT? So this is a little bit tricky. So actually, we need to remember that. Okay, so because I don't think the MIPS sheet tells you which one is RS, which one is RT. Yeah, it doesn't. Okay, so now what can we do? We have to remember that. So RS is the source, right? And RT is the target, and RD is the destination. So among the MIPS instruction, which one is the destination? The first argument is the destination, right? So you have RD, and the first source is the second argument, and the last one will be the target. So source register, RS is always the first operand, okay, of the operation. All right, so now let's fill in the blank and be careful, okay, because in the instruction in MIPS, RD is the first register, but in the machine code, RS is the first register, so be careful, all right? So you put RS, which is 8, RT, which is 4, RD, which is 16. What about shift amount? Are we doing any shift? No, right? So whenever we don't use a field, we just put 0. That's all. And now all you need to do is, based on the number of bits in the field, you just convert them into zeros and ones. So I have opcode, RS, RT, RD, shift amount, and function. Okay. So again, you have 6, 5, 5, 5, 5, 6. All right. So opcode is 0, 1, 2, 3, 4, 5, 6. RS is 8, 5 bits. So I have 0, 1, 2, 3, 4. And RT is 4 with 5 bits. I have 0, 0, 1, 0, 0. 16, 5 bits. 1, 2, 3, 4, 5. Okay. And then shift amount is 0, so you have 5 zeros. And then function code 20. So again, this is hexadecimal already. So all you need to do is just convert it into binary. So I have 2, which is 1, 0, 0, 0, and then 4 zeros at the end. So now totally you have 6 bits. Okay. So now what do we do? Convert that into hexadecimal. So group them into groups of 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, and then now you convert them into your hexadecimal. So you have 0, 1, 0, 4, 8, 0, 2, 0. Okay, so now your answer will be 0, 1, 0, 4, 8, 0, 2, 0. And this is the machine code that's going to store into your memory, or when it's translated, it will be in your executable. So that's good. Okay, so finally, let's do one more R format. So what is our format? Let's use a shift operation so that I can utilize a shift amount. Okay, so now let's do that. Let's use set and not set shift logical or shift left logical. Okay, and then T1, T2, and then 5. Okay, so in this case, I know that this is our format, right? And the next thing is we need to find out which one is RS, which one is RT, and which one is RD, because we don't have 3 registers in this case, right? I know that this is going to be shift amount, right? This one will tell me what function call I should use, right? Because our format opcode is always 0. So now the question is which one is RS, which one is RT, or even RD. Okay. And again, what does shift left logical does or do? We shift what's in T2 with 5 bits to the left, right? And save the result to T1. So T1 will be definitely RD. Okay, so now what about T2? Is it RS or RT? What do you think? Let's flip a coin, right? No, you can't flip a coin because when you flip a coin, you have 50% wrong. Okay, so now let's go back to the MIPS sheets and take a look at it. Okay, so now go through the MIPS sheets, find shift left logical. And what do you see? You're shifting what's in RT to the left by the amount, right? So you can see that we're using RT in this case. Very tricky, right? And what is the function code? 0, all right? So now let's go back to our screen. Okay, now, which means that this is RT, function code is just 0. Very easy, right? So now again, draw the fields, opcode, RS, RT, RD, shift amount function. Well, it's not proportional, but doesn't matter, right? Opcode, RS, RT, RD, shift amount function. All right, so we know that opcode is always 0, function code is 0. And what is RT or RS? RS is 0, right? So what is T2? So T2, T0 is 8, right? So T2, so T0 is 8, T1 is 9, so T2 will be 10. And T1 will be 9, right? So I put RT, which is 10, RD, which is 9, shift amount, which is 5. So now convert them into zeros and ones. Okay, so I have 1, 2, 3, 4, 5, 6. Because again, 6, 5, 5, 5, 5, 6, right? 1, 2, 3, 4, 5. 1, 2, 0, right? So this is 8. I mean, this is 10. And 9 is, right? And then 5 is, and then 6 bits of 0. Okay, so this is your machine code. And now let's convert that into hexadecimal. Again, group them in groups of 4. How come I have a purple? Well, doesn't matter. 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Interesting. Keeps changing color. 1, 2, 3, 4. 1, 2, 3, 4. Okay. And now let's write down the hexadecimal. 0, 0, 0, 8, 4, 9, 4, 0. So again, in your exam, you really have to, I mean, before the exam, I should say, you really have to practice the conversion between zeros and ones and hexadecimal quick, or even binary, zeros and ones and base 10, because it really requires you to be able to do it quick, because If you do it slowly, then it's just taking you too much time to do one problem. Okay, and only 4 bits, right? So the value is from 0 to 15. It's not that difficult to remember. Okay, so try to do it fast. Okay, so the answer will be 0008 4940. Sounds good? So this is your machine code for shift left logical with T1, T2, and shift among is 5. Okay, so I'll stop here, and then with the next video, I will go over the I format. Okay, make sure you practice, come up with some examples of our format, and then keep on practicing. Okay.